All right, last video on this lesson. So it's nice to kind of get through this. There were a lot of things to work on and learn here, but we're gonna, need to be very comfortable knowing, excuse me, knowing all of the vocabulary terms, knowing how to apply them, and then just kind of the little tricks and something, the formula we found out about for axis of symmetry. All of that's very important to just kind of knowing how to graph these and knowing how to understand them. So we're going to look at a problem now where we're actually going to use this to help us predict something. As you may or may not know, whenever you throw something, it does this, it takes this track that they call a parabolic trajectory, right? And so it rises up to a certain point, and then gravity takes hold, and then it starts to come down. But generally speaking, when you throw something, so supposing you're standing, over here, right? And you throw a rock, and that rock's usually going to go, it's going to go up, and then it's going to come down. And no, sorry, not like that at all. It's going to, come down to the earth. And it usually follows something similar to a parabola. And it may not always show all parts of the parabola, but it will have a relatively parabolic trajectory, which is the term they use. So you're gonna use a lot of examples and see a lot of examples that involve throwing things. So here we go with one of them. Emilio is competing in the javelin throw. All right. The height of the javelin can be modeled by this equation, negative 16x squared plus 64x plus 6, where y represents the height in feet of the javelin after x seconds. They want us to graph this. At what height is the javelin thrown? We want to figure that out. And then they want us to tell them what's the maximum height of the javelin. So I'm going to do something really here. We're going to go to another page. And I'm going to change it so that we have some graph paper that we can use. All right. So we want to graph this. So let's go back to our equation. And negative 16x squared minus 64x plus 6. All right, so negative 16x squared plus 64x plus 6. Pretty sure that's what it is. Yep. All right, so let's graph this thing. So let's take, I'm going to take my, I'm going to draw a line here. All right, and then you notice I'm drawing this differently. Why am I drawing it like that? Why am I not making the regular general X, in the middle like this? Well, the reason I'm not doing that is because think about the application here. The application is this is a real world problem. So most real world problems happen in quadrant 1, where everything's basically positive, because Emilio's not throwing this thing below ground, so it's not going to be down here, and he's not throwing it in negative time, because that just doesn't happen. So this is all happening here, right? So this is our time, this is our height. Make sure I got that right, but I'm pretty sure I do. And then with that, right, y represents the height in feet. Yep, javelin, all right? So this is height in feet. This is time in seconds. All right, so if we're going to graph this, it would be really helpful to know any of the things, the features we need to know. So think of the features we know. Well, if we knew the y-intercept, that would be helpful. It would be helpful to know our x-intercepts, right? So in other words, where y is 0, that would be helpful to know. It would be helpful to know our axis of symmetry. And it would be helpful to know our vertex. And once we know that, we'll be able to figure out and answer the other problems. So just for graphing this alone, all right, so let's switch over. So let's start by finding our y-intercept. So our y-intercept is the point at where x is 0, because your y-intercept is this line right here, your y-axis, and x is, that's at the point where x is 0, and we want to see what that is. So remember that little trick we did where we look at this? Well, if this is 0 and this is 0, these terms basically cancel out, right? And so you're just left with that. So my y-intercept is 6. So I'm going to go 1, 2, 3, 4, 5, 6. I'm going to put a point right here. And you know what I'm going to do is I'm looking at this, and it looks like these values could get kind of big. So I think I'm going to undo this, and we're going to go by 2. So we'll say 2, 4, 6, and we'll put this right here. And then we'll leave the time in ones. All right, so we'll say this is 2, 4, 6, like that, and we'll leave time like this, and we'll see how that works out. All right, now to find the x-intercept is where y is equal to 0. Well, you don't really know how to do that algebraically yet, but that is what we would be looking for. So I think we're going to hold off on that, and you will learn how to do that pretty shortly in a couple lessons. Let's find our axis of symmetry. So our axis of symmetry, right, is going to be the point negative b over 2a, right? X equals negative b over 2a. So negative b is going to be negative 64, and then 2a is 2 times negative 16. So that's going to give you negative 64 over negative 32, which is 2. All right? So my axis of symmetry is this point right here. That means, right, that is going to be where this thing kind of, it goes around that. So I'm going to have something that's, going to be, like that, or, and I didn't even draw that right. It would have to be, like something like that. And the only reason you can't see any of that other stuff over there is because, he's holding it, right? And we'll talk about that in a minute. So let's figure out where that vertex is then, so we can do an accurate representation of this. Okay, so the vertex is we're going to take this number and we're going to put it in the equation. So we're going to go negative 16 times 2 squared plus 64 times 2 plus 6. All right, so negative 16, 2 squared is 4. 4 times negative 16 is negative 64. And then we're going to get 128 over here and then plus 6, right? And so negative 64 plus 128 gives you 64, plus 6 gives you 70. So the point 2, 70 is going to be your vertex. So that's going to be way up here. So what we're going to want to do is we're going to want to change this so that we are doing this. Let me put my line back here. We're going to want to change this so that it is numbered probably by 5s. So let's do that. Let's number it by 5s. So this will be 10, 20, 30, 40, 50, 60, 70. All right, so I know it goes up to 70. So it starts down at, what did we say it was, 6, right? Which is right here about. Goes up to 70, and then it comes down, right? And so basically a rough representation of that's going to look something like that. It's not the best, but that's kind of what it's going to look like. And you don't have to draw your axis of symmetry when you do these. I just do it because it's kind of a visual representation for me. All right, so now we've drawn our graph of it. It's also asking us, at what height is the javelin thrown? Well, the javelin is thrown at time 0, right? At time 0. When t equals 0 is when the javelin is thrown. And so your time is x, right? So we already figured that out. When x equals 0, that's our y-intercept. So our y-intercept, believe it or not, is very useful. That's how high the javelin was when it got thrown, because that was the time 0. So to answer B, it would be 6 feet. That is the height the javelin was at when it was thrown. And then what is the maximum height of the javelin? Well, look at your picture, right? Look at your parabola. It is 70. We determined that, the vertex. So you see how these markers are really kind of important to us. All right, so maximum height is 70 feet. And then at that point, you are finished. So hope this made a little bit of sense to you, and good luck with the problems.